Even though the two Voyager probes have been traveling through space for 47 years now, their research mission continues tirelessly, constantly revealing new discoveries that expand our understanding of the universe. Despite the enormous distance and the incredible amount of time that has passed, the Voyager 1 and 2 probes continue to send back data that fascinates and surprises scientists. These data reveal a myriad of cosmic and mysterious phenomena that challenge our knowledge, offering new perspectives on the structure of interstellar space and the behavior of particles and magnetic fields beyond the solar system. After surpassing the boundaries of the solar system, the Voyager probes are now in an unexplored region where the conditions are so extreme and mysterious that every new discovery becomes a crucial piece in understanding the universe. One of the questions that continues to inspire wonder is, what lies at the heart of interstellar space? The probes have revealed the presence of unexpected magnetic walls that seem to act as a shield against cosmic radiation and could provide fundamental information on the interactions between our solar system and the interstellar medium. But what continues to astonish astronomers is that, despite the extraordinary discoveries, there is still so much we do not know. The Voyager missions are like the first pages of a cosmic book that invites us to explore ever deeper, but that does not easily reveal its secrets. One event that particularly shook the scientific community was what happened to Voyager 1 in October 2022, when the probe recorded the most powerful gamma-ray burst ever observed coming from interstellar space. This phenomenon not only caused amazement, but also raised a series of questions about its causes and its impact on our cosmological model. The intensity of the burst was such that almost all space observatories had difficulty handling the data, and it was immediately clear that something unprecedented was happening. This event, while spectacular, highlighted a gap in existing theoretical models, as the explosion and its glow did not correspond to any known forms of radiation. Astronomers are now searching for new explanations, trying to understand what could have triggered such a powerful and enigmatic phenomenon. Looking at the history of the Voyager probes, their launch on August 20th and September 5th, 1977, marked the beginning of one of the most successful space missions ever. When they were launched, the probes were intended for a limited duration mission, with the goal of exploring the outer planets of the solar system and their moons. The images and data collected by these probes forever changed our way of looking at the solar system, revealing worlds and phenomena never seen before. NASA, recognizing the importance of these discoveries, decided to extend the mission, sending the probes farther and farther to the edges of our solar system and beyond. This was the beginning of an extraordinary journey that saw Voyager 1 and 2 venture deep into interstellar space. In 2012, Voyager 1 reached a historic milestone. It crossed the Sun's protective magnetic bubble, known as the heliosphere, which marks the boundary between the solar system and interstellar space. 6 years later, Voyager 2 followed in its footsteps, also crossing the heliopause. These events marked the first journey of a human-made object beyond the protective boundaries of our solar system, an achievement that had only been imagined by scientists until that moment. Today, the Voyager probes are at incredible distances from our Sun, at 24.8 and 20.7 billion kilometers, respectively. These enormous distances offer scientists a unique view of a part of the universe that no other human instrument has ever observed so closely. One of the most fascinating aspects of the Voyager missions has been the opportunity to observe the interactions between our Sun and outer space. Thanks to the data collected by the probes, scientists have been able to study in detail the behavior of plasma and magnetic fields outside the direct influence of the Sun. For example, Voyager 1 detected a significant change in plasma currents before crossing the heliopause, a phenomenon that led to the discovery of turbulence in the interstellar plasma surrounding our solar system. Voyager 2, on the other hand, recorded different conditions, crossing the heliopause in a shorter time and without encountering the same plasma turbulence. This contrast provided scientists with new information on the dynamic nature of the heliopause and the fluctuations in solar activity that influence the behavior of the interstellar medium. One of Voyager 2's most surprising discoveries was the revelation of a magnetic wall on the side of the heliopause closest to the Sun. This magnetic wall, which acts as a protective shield against cosmic radiation, has a unique structure and a much stronger magnetic field than any other measured in the heliosphere. What makes this magnetic field so interesting is its dynamic nature and its behavior in relation to solar activity cycles. Scientists believe that the magnetic wall is generated by magnetic currents moving toward the heliopause and distributing laterally, with the direction of the field changing cyclically depending on solar activity. This phenomenon offers new perspectives on the behavior of the Sun's magnetic field and its interaction with the interstellar medium. Despite all these extraordinary discoveries, the true nature of interstellar space remains a mystery. The Voyager missions have provided us with an unprecedented view of the outer regions of our solar system, but we are only at the beginning of our exploration of this vast and uncharted cosmic realm. Future missions, such as those aimed at exploring nearby stars or studying anomalies in interstellar magnetic fields, will be essential to completing our picture of the universe and addressing the questions raised by the Voyager probes. Looking at the technologies that made these extraordinary successes possible, it is astonishing to think that the Voyager probes were designed in the 1970s, a time when space technology was far more primitive than today. Objects like smartphones, which today have processing and memory capabilities immensely superior to those of the probes, demonstrate how far technological progress has come in just a few decades. Yet despite the technological limitations of the time, the Voyager probes have endured thanks to an energy-saving plan designed to maximize the duration of the missions. This incredible longevity demonstrates the ingenuity and perseverance of NASA, which has managed to keep outdated devices operating in extremely harsh conditions beyond all expectations. In 2022, Voyager 1 marked another important chapter in its long career when it detected an extraordinary phenomenon: a powerful gamma-ray burst from interstellar space. This event, a gamma-ray burst, GRB, shook the scientific community, as its intensity and nature were not predicted by existing models. Scientists have hypothesized that the gamma rays originated from a particular type of stellar explosion, in which massive stars rapidly collapse, emitting jets of particles traveling at nearly the speed of light. This event challenged existing theories and pushed astronomical research toward new frontiers. With each new discovery, the Voyager probes continue to push the limits of our knowledge, bringing humanity ever closer to understanding the mysteries of the universe. Thanks for watching. Leave a like and subscribe to the channel to avoid missing upcoming videos.